So this is going to be a quick video on stem plots or stem and leaf plots. So we're graphing quantitative variables. Stem plots or stem and leaf plots show a quick picture of the data distribution, including the actual numerical data in the graph. Stem plots work best for small numbers of observations, and you'll see why. So to make a stem plot, we first separate each observation into a stem consisting of all but the final rightmost digit and a leaf, the final digit. Stems may have as many digits as needed, but each leaf contains only a single digit. Write the stems in a vertical column with the smallest at the top and draw a vertical line at the right of this column. Write each leaf in the row to the right of its stem in increasing order out from the stem. So here's an example of a data set that we might want to make a stem plot from. First, we look at the data and try to understand the range of our data. This data looks like it goes from 16 all the way up to 51. So we have data points in here everywhere from 16 up to 51. So to look back and figure out what we need to do to make a stem plot, it says first we have to separate each observation into a stem consisting of all but the final rightmost digit and a leaf, the final digit. So that would mean if we had a number like 16, that we'd split it all but the final rightmost digit. So in the case of 16, the final rightmost digit is the 6, and the left digit here is the 1. So this is the tens place, and this is the ones. So what we do to make a stem plot, we draw our line. This is to split the stems, and this to split the stems from the leaves. So here, all of our digits are between 16 and 51. So we're going to have this be our tens, and this side's going to be our, let me rewrite that. This will be our tens. This side will be our ones. So in this case, we start at the bottom with our tens, and the first digit we have is 16. So we have nothing that falls below a 10. So we're going to start writing a 1 there, because our first number is 16. So to write 16, we would write 1, 6. 6 would be in the ones place. But first we're going to fill out all of our stem here. So the next one will be a 2. So we've got plenty of 20s. Then we need a 3, a 4, and a 5. So now we've got the stem in place. Now it's time for us to start filling in the leaves. So the first leaf we're going to come to is 16 here. So as we come to each number, I like to cross them off to know that I've used it. So 16 would look like this. 1, 6. There's a 10 and there's a 6 for 16. The next number is 43. So 43 has a 4 in the 10 spot and a 3 in the 1 spot. 38, go here. We just go through 48, 42, 23, 36, 35, 37, 34, looks like we have a lot of 30s, 25, 28, 26, 43. So we've already gotten 143 here. But just because we have 1 doesn't mean we only write it once. We have to write every instance as a separate leaf on the stem. 51, 33, 40, 35, 41, and finally 42. So many people stop here. So this is a stem and leaf plot. Now we can see that most of our data falls between the 30s and the 40s, and we can kind of see a little bit of a structure or a shape to our data, which we're going to use in the future. The next step in making a proper stem plot is to put all of these leaves in order. So we don't want it to go 3, 8, 2, 3, 0, 1, 2. We want it to go 0, 1, 2, 3, and so on. So we need to put them in order. So here's the stem plot we just constructed by following 16, 43, 38, 48, in the exact order that we did it. The next step is to order these. Put all these leaves in order. In this one, you notice that 3, 5, 8, 6 goes to 3, 5, 6, 8, because that's the correct order, from lowest to highest, left to right. So here we go, 0, 1, 0, 1, 2, 2, 3, 3, 8. We never omit our leaves. If we have multiples, we need to keep those. If we omitted them, we would lose the visual aspect of the stem plot that makes it so valuable. So what else can we do with stem plots? So we can do something called a back-to-back stem plot. If you're comparing two groups, such as girls and boys, this allows us to use one stem plot and get a visual representation of what's going on. So if we look at the data in the girls and the boys, a single stem here in the center is going to be useful for making both stem plots. So the way you make a back-to-back stem plot is you start with maybe the girls here, and you start that stem plot shooting off to the left. So we'd come through here and we'd find 16 is the first number, 43 is the next, so we come down and write 43. These are all already ordered. So these are all in order from lowest over to highest, from right to left. So they go from the stem outward in increasing size. The boys we make on the other side. So the boys we're going to make out to the right. We start with the number 8 here. That's our first one. So 0, 8. Then we've got a 12 and an 18 and so on. So from this we see a visual comparison of vitamin D level in blood comparing girls and boys. We can see that on the whole, the girls seem to have higher levels of vitamin D in their blood than the boys do. Another fun thing we can do with stem plots, when we have too much data, when we have a lot of data points like this, sometimes it's more helpful visually to see what's going on with a stem plot if we do what's called splitting the stems. So instead of having 1, 2 with all of these data points coming out to the side, we split it into 2s. So in this case now we have 0, we put 2 1s, 2 2s, 2 3s, 2 4s, and 1 5. There's only 1 0 and 1 5 because there's only one value in each of those. So it's not really necessary to put 2. Make note that those are on the very outside edges. If those happened in the center, you would need to put 2 of them there. So like in this case, where the 4s are, well, we put 2 4s there. We could also just write another 5 here. There's no harm in that, or writing another 0 there. So this would go from 0 to 4, and this would be from 5 to 9. This number 1 here, all the values we'd put beside that 1 would be numbers from 0 to 4. This one would get 5 to 9. So this would be 0 to 4, and this would be 5 to 9. So numbers from 10 to 14, and numbers from 15 to 19. So the stems are split in that way. Splitting stems allows us to get rid of these big peaks here and shows us a better visual representation of what's going on with our data.